Good day, students. Welcome to mathgotserved.com. In this clip, we're going to be going over how to apply the quotient property of exponents. Before we get started, let's consider the formula that's going to guide our problem solving process. Okay, so formula. Actually, we're going to look at two formulas. The first one is the main one we're using, which is the quotient property of exponents. Now, the word quotient basically means division, okay? So it's the division property of exponents. So the quotient property of exponents is as follows. If you are dividing two exponents, let's say x to the a and x to the b, two exponents of the same base, what you do is simply subtract the exponents a minus b, okay? And then the second property might occur in the process of using this quotient property, and this is the reciprocal property of exponents. Okay. The reciprocal property of exponents basically applies to scenarios where you have a negative exponent. So if you have x to the negative a, this negative indicates an operation, and that operation is reciprocation. So if you have an exponent with a negative exponent, if you reciprocate that term with a negative exponent, you end up with the opposite of the sign of the exponent. So this would be 1 over x to the a. Okay, so this is the reciprocal property of exponents. All right, let's take a look at some problems. The instructions are for us to simplify the following. So question 1, let's say we have the quotient 2a to the fourth, b to the third, divided by 4a square b. All right, so let's go ahead and simplify this. I'm going to rewrite the problem. 2a to the fourth, b to the third over 4a square b. All right, let's start by dealing with the numbers. Okay, so we can divide top and bottom by 2. If we divide the numerator by 2, 2 goes into 2, 1, and 2 goes into 4, 2. We're dividing by 2 because the greatest common factor of 2 and 4 is 2. I assume you already know that. Now let's go to the application of the quotient property of exponents. Okay, so now in the numerator we have 1 times, and in the denominator we have 2 times. Now if you look at the a's, you have a to the fourth and a to the second power. The reciprocal property of exponents just means that when you're dividing these two, you subtract the exponents. Now you can be strategic with the order of your subtraction because it could save you a reciprocation step. So the fastest way to do it is to divide out or cancel out the exponent with the smaller power, and then subtract that power from the identical base exponent with the bigger power. Okay, so you have a to the fourth and a to the second power. Let's focus on these two, a to the fourth and a to the second. Which one has a bigger exponent? Clearly, a to the fourth, the numerator exponent term, base a, has a bigger exponent. So what we're going to do is divide out the a squared in the denominator. That's going to be 1. And then what we're going to do is we're going to subtract. You see this 2 right here? We're going to subtract it from the power on the top in the numerator. So that's going to be a raised to the 4 minus 2. This 4 minus 2 basically indicates the division process as indicated by the quotient property of exponents. Now let's take a look at the b's. This b has no exponent, so the default exponent is going to be 1. Now what we're going to do is, since these two have identical bases, we're going to look at the powers and ask which one is bigger. The numerator exponent base b has a bigger power. So what we're going to do is we're going to subtract the power from the smaller from the bigger. Okay? So to avoid making mistakes, we're going to divide out b to the 1 from the denominator. That's going to be 1. And when we divide b to the first power into the numerator, all we have to do is simply subtract 1 from the power. Subtract the power from the denominator from the power and the numerator, and that's how you divide using the quotient property of exponents. So this will be times b to the 3 minus 1. Let's go ahead and simplify that. This is going to be a to the 4 minus 2 is 2. B to the 3 minus 1 is just 2. And then I have a 1 here and then a 1 there. And when you multiply all that together, in the denominator, you just be left with 2. So the final answer for the first problem is a squared b squared divided by 2. All right, let's take a look at another example. Now let's say we have the quotient number 2, 2y x to the third z square divided by 2y square. All right, let's do this one. All right, so we have 2y x to the third z square over 2y square. Now, let's make sure all the exponents have, all the factors have powers, okay? So y here doesn't have a power, so the default power is 1. Okay? So we start by the 2's. We can divide the numerator and the denominator by 2. So 2 goes into 2 ones, and 2 goes into 2 ones. The 2's divide themselves out completely. Now let's shift our attention to the x's. We want to put it in alphabetical order. Okay, so x to the third just stands alone. There's nothing to subtract that from. So we're going to have 1 times x to the third. That stays in its original position, which was in the numerator. Now let's take a look at the y's. We have a y in the numerator and a y in the denominator. So what we're going to do is take a look at the powers, okay? You look at the numerator power for the y is 1 and the denominator is 2. Which is bigger? The denominator is bigger. Okay, so we're going to divide or cancel out the y to the first in the numerator, put a 1 there, and divide this by that power, which can be carried out by subtracting 1. Okay, so y to the first power goes here once, and into the second power, you just subtract the power of y to the 1 that you divided y to the 1 by. Alrighty, so that yields in the denominator y to the 2 minus 1 times z squared doesn't have anything to divide with in the denominator, so z squared stays unchanged. So your final answer is going to be x to the third z squared divided by y to the 2 minus 1, which is just y to the first power, which can be written as just y. Okay, so there goes the answer to question number 2. Alright, let's take a look at one more problem, and then we will give you some practice problems to try out to demonstrate mastery. Question number 3. What if we have negative 3 x to the negative third power y squared z to the fourth, this entire product divided by negative 4 x squared y to the third z to the second power. Alright, let's do this. So let's just rewrite it. So negative 3 x negative 3 y squared z to the fourth divided by negative 4 x squared y cubed z to the second power. Alright, so we're going to start out by dividing the signs. Remember, whenever you divide identical signs, you always end up with a positive. So Minus over minus is going to be plus. You just slash and dash. So that's plus. Now 3 and 4 do not have a common factor, so 3 and 4 will remain. 3 in the numerator, 4 in the denominator. So we have positive 3 times, and then 4 times in the denominator. Okay, now let's move on to x. We have x to the negative 3 in the numerator and x squared in the denominator. So the question is, which one is smaller? X to the negative 3 has a smaller power than x squared. So what we're going to do is we're going to cancel this out or divide it out and subtract it from the denominator, okay, because it's bigger. So x to the negative 3 goes into x to the negative 3 one time, and then here is going to be minus negative 3. Okay, so let's write it over here. So you're going to have times 1 on the top, and then in the bottom is going to be x squared minus negative 3. So we are subtracting a negative number, minus negative 3. Okay? Now let's take a look at the y's. In the numerator, you have y squared. In the denominator, you have y to the third. So which is bigger? Clearly, the denominator has a bigger exponent. So what we're going to do is we're going to cancel out the smaller or divide it out. Y squared goes into y squared once. And then the denominator, we're going to subtract the power of the term that we canceled out. So minus 2. So that gives us, in the denominator, another factor, y equals 3 minus 2. Okay? Now let's take a look at the z's. What do we have for the z's? For the z's, we have, let's see. So this is the y is just 1. For the z's, we have z to the fourth in the numerator is bigger than z squared in the denominator. So what are we going to do? We're going to cancel out the smaller or divide it out and subtract its power from the bigger. So z squared goes into z squared once, and then we subtract that power from the bigger one in the numerator. Okay, so that becomes 3 times 1 times 1 times z to the 4 minus 2. Okay? Now, if we multiply all that together, so there's just 1, multiply everything together, we're going to have in the numerator 3z to the 4 minus 2. 4 minus 2 is 2, divided by, in the denominator, 4x. Now look at this. What is 2 minus negative 2? When you multiply identical signs, just like division, you always end up with a plus. So you can slash and dash there. And then you get a plus. 2 plus 3. Okay? What's 2 plus 3? 2 plus 3 is 5. So we have x to the 5th power. And then for the y's, y to the 3 minus 2. 3 minus 2 is 1. So it's just y to the 1st power, which can be written as y. Okay? So in the examples that we did, we were strategic and we didn't end up with any negative exponents. In some problems, ending up with a negative exponent is inevitable, so you will just have to apply the reciprocal property and flip that term with the negative exponent so that the exponent becomes positive. Alright, so this is the answer to question number 3. So this is e squared. Alright, so how well did you master the contents of this presentation? To demonstrate mastery, we'd like you to try out the following problems. Okay, so you just basically copy down the problems, pause the video, try out the problems. When you're done, you click back on the play button, and you will see what the answers are. Okay, so the instructions are to simplify the following. Alright, so what if we have for question 1, we have for u to the third power, v to the third power, divided by 4u squared v to the fourth. Number 2, what if you have m to the fourth power, n to the second power, divided by 2m to the third power, n to the third power. Number 3, what if you have 4a to the third power c squared divided by negative 2a to the negative 4b to the third. And then lastly, what if you have 3q to the fourth r squared divided by p to the third q to the negative 3 r to the negative 3. Okay, so go ahead and pause the video at this time and simplify the following expressions. Click back on play to see what the answers are. Alright, hopefully you had a chance to work out the problems. The answers to these problems are as follows. For number 1, the answer is u over v. For number 2, the answer is m over 2n. For number 3, the answer is negative 2a to the 7th power c squared divided by b to the third. And then for number 4, the answer is 3q to the 7 r to the 5th divided by p to the third. Thanks for taking the time to watch this presentation. Let us know what you think. If you found the contents of this tutorial helpful in your studies of exponents, to give us a thumbs up. Your positive feedback is very valuable to us. If you have any questions or comments about the contents of this presentation, or you want to request any math tutorials in general, just place it in the comment section below. Do not forget to subscribe to our channel for updates to other math tutorials such as this. Tons of support resources and tools to help you in your study of mathematics can be found on our website at mathgotserved.com. Do check it out. Thanks again for watching and have a wonderful day. Goodbye.